Good evening and welcome to this technical session on air quality. My name is Richard Alper and I'm the chair of the Larimer County Environmental Science Advisory Board. I'd like to begin by asking the members of the City Air Quality Advisory Board to raise their hands. Welcome and thank you. And the members of the City Natural Resources Advisory Board to raise their hands. Glad you're here. Welcome. And the members and staff from the County Environmental Science Advisory Board, raise your hands. Thank you. And so I want to introduce you to Ginny Sawyer, a employee and staff of the city who will be our facilitator tonight for questions and answers. And then we'll get started with our speakers.
Thank you, Richard. Thanks, everyone, for coming out. It's nice to see an engaged group on all sides coming forward. If people want agendas, they're in the back, but we have 3 presentations for the evening. We will have time for Q&A at the end of each presentation, so I'm going to ask that people hold their questions, and then I will do my best to keep us on time and be respectful of time as we go forward. We are recording this, so in order for that to work on the audio, I'm going to ask the presenters to use the mic at the podium when they're doing that, and then I will do my best to repeat any questions, 1, so that everyone hears, and 2, so that we catch it on the audio. And with that, I think Cassie's going to kick us off.
Yeah, thanks, Ginny, and thank you to the boards, actually, for having me. I only have a really quick presentation to start us off. So I'm Cassie Archuleta. I'm Air Quality Program Manager here at the City of Fort Collins with the Environmental Services Department. So I only had a few slides to just talk a little bit about ozone. What is ozone? Before we handed it off for the more technical presentations. So it's a quick update. What is ozone? So ozone is an air pollutant that is not emitted directly from sources. It's formed through photochemical reactions. It's sunshine driven, so that's why we talk a lot about ozone in the summertime. The things that contribute are fossil fuel combustion emissions, things like nitrogen dioxide and other nitrogen oxides, and evaporative emissions like biogenic, petroleum-based evaporative emissions, volatile organic compounds. And when we talk about ozone, we talk about it being good up high and bad nearby. So up high in the stratosphere, you've probably heard of the ozone hole and how things are improving there. Ozone absorbs UV. That's a good thing up in the stratosphere. Now down at ground level in the troposphere, it's actually very reactive with our lung tissue. So high levels of ozone has been characterized like kind of a sunburn on our lungs. So we don't like high levels. And for that reason, because there are health effects, the EPA does have standards for ozone. There are a couple different standards, and we are considered a non-attainment area for ozone. So this is a picture of the U.S., and circled there is our non-attainment area. That's the Denver Metro North Front Range ozone non-attainment area. We have a standard of 75 parts per billion, and we measure higher than that. So we have a couple places where we measure ozone. We measure higher than that. And we've gone through a couple different designations, things like marginal, moderate, and then something else. We have a new standard that's been adopted, and there might be some designations related to that still coming this year. So a little bit about the measurements. So we measure, this is a zoom in of our non-attainment area, actually, and you can see there are 2 monitors in Fort Collins. You can see the one circled in orange. That was our 2015-2017 design value. That's a value that's compared to the EPA standard. So this year we got below the older standard, but we're still higher than a newer standard is what that's showing. And then along the non-attainment area, we have a few sites that are higher than the standard. So we continue to be part of this non-attainment area. It's drawn around this region that is supposed to encompass most of the emissions that contribute to our local contributions to ozone. There's a lot of ozone that comes from other places. We make a lot of it too, and that's supposed to draw kind of a shape around it. So measurements over time, I just pulled up this EPA Air Quality Index to kind of show you the number of days where we measure high. So how this translates day to day is we'll get good days, moderate days, some days that are classified as unhealthy for sensitive groups. That might mean elderly or the children. And if you watch things like air quality alerts, that's what this is related to. It's going to be an orange alert day. So if you're a part of a sensitive population, you might want to spend more time indoors, maybe not exercise outside during the middle of the day. And you can see that our unhealthy for sensitive group days are going down, those orange days. So over time, our ozone situation has gotten better, but it's still not great. We're still part of a non-attainment area. And what contributes to that? So that's a lot of what we're going to talk about today. So what are some of our air quality challenges? Our population is growing, lots of traffic that contributes, and we have oil and gas wells in the region. So I have the picture from the Colorado Oil and Gas Conservation Site that shows the active oil and gas wells in the region. Those certainly do contribute to some of the ozone-causing pollution, along with the cars, and that's a lot of what the next presentation is going to talk about, is some air quality studies related to that and what it means and how those things have been apportioned. And that is really what I brought. So I just wanted to give a really brief introduction on ozone, what it is, a little bit of a setup for the other presentations, and here's my contact information with the City of Fort Collins. We do a lot of outreach related to air quality, and then also the Larimer County contact for that, Leah Schneider, who wanted to be here today. She was going to do this update and sends her regrets that she couldn't make it.
Any initial questions for Cassie? Should we just get this show on the road? All right, we'll get this show on the road. So our next presenters, I should have looked ahead of time. Gabrielle, and yeah. So the comment is from someone new to the area who is surprised that we're noted as a non-attainment area based on really sort of 9 unhealthy days.
Oh, sure. Yeah. So the latest ranking, so the American Lung Association, they put out a report annually with a ranking that ranks cities. Their newest one, the one that was released just this year, ranked values measured through 2015. And they use a different metric than the EPA uses. So the EPA is looking at a 3-year metric, 4th highest kind of thing. What the American Lung Association is looking at are these stats right here. Like, how many days are you getting that are in those orange to purple categories? Their latest report included 2013 through 2015, and they ranked us as number 15 as most ozone polluted cities in the nation. They rank us pretty clean on particulate matter, but not so on ozone. So we actually expect that rating to improve a bit as this 2016, 2017 these numbers get rolled in. That said, though, we still do have an ozone issue, and the orange, that would be starting at 71 parts per billion and higher. Oh, yes. Sorry, it's probably translating odd on the TV. It is based on number of days in this unhealthy for sensitive groups and higher. No, it has nothing to do with particles. It's only based on ozone readings, the American Lung Association rating. We do not have an attainment issue with particulate matter. Ozone is our only non-attainment issue. The question was, do other air toxics in the area, for example, benzene, do those fall or impact the ozone measurements? Was that correct? And I'll say that ozone is formed in the atmosphere as a result of other pollutants, and there are things that will affect the formation of ozone, but these numbers specifically are just about that final ozone product. So there's relationships there, but no, this isn't going to directly reflect what you might see in a benzene concentration. The question is, would benzene play a part in the ozone? And that might be something that Gabby and Frank's presentation can get a little bit more into, is how the reactions happen. So benzene and other VOCs do play a part in ozone reactions, but the measurements that we have are really only measuring ozone. So all we know is the ozone value. We don't know from that value what contributed to it, just from this measurement.
All right, so yeah, thank you, Cassie. Thank you, questions. Let's move on and bring our next presenters up here, and we will get going. And if you two could introduce yourselves. This microphone works, and I'll give you this one.
So I'm Gabriele Pfüsser, and I'm here with Frank Flake, who will take over then later. And we are at NCAR in Boulder at the National Center for Atmospheric Research. And we have been working on a monitoring network assessment report for the city of Fort Collins on request and thanks to the funding of the city of Fort Collins. Maybe just a quick follow-up on the benzene and the ozone. I think we're talking about here, yes, like Cassie said, benzene contributes also to some part to ozone production. But I think when you refer to the benzene concentrations themselves, I think you're less worried about really specifically how much this one specific volatile organic compound contributes to the ozone concentrations, but more about the toxicity of the benzene itself. That's the bigger issue. Now, benzene is not part of an EPA criteria pollutant. There is no, like for ozone, ozone is one of the 6 criteria pollutants that's regulated by the Clean Air Act. And there is a national ambient air quality standard for ozone, as well as for PM 2.5, which is another criteria pollutant. The air toxics are not criteria pollutants. So they are regulated in a very, very different way. And that's a big difference. We can maybe discuss that later. I'm also not a lawmaker or regulator. But I said benzene or any of the air toxics have very different regulations than a criteria pollutant. There is plenty of information on the EPA website if you look up Clean Air Act. Right, but from there you get also links that tells you about the air toxics. But there is, for example, there is no clear US threshold for the allowed values of air toxics in the air. There can be a value, can be different in California than it can be somewhere different in any other state. It's just not as clear-cut a problem. But it's definitely not a question that the air toxics are dangerous to our health. Okay, so let's move maybe away from, so as I said, so we have been working on a monitoring network assessment for the city of Fort Collins. And our main problem, or our main focus is also ozone pollution. Like Cassie said, the Front Range is in non-attainment of the ozone concentrations, and ozone is dangerous to our health. A main motivation for our work has been a big field campaign that took place in summer 2014 here in the Colorado Front Range, and I'm not sure some of you might remember it. It was a merger of actually 2 major field campaigns. The FRAPPE campaign, Front Range Air Pollution and Photochemistry Experiment, which has been funded by the state of Colorado and by the National Science Foundation. The National Science Foundation provides core funding to NCAR. Discovery Q was the other big study, and that has been funded by NOAA. And we also had a lot of in-kind contributions, by NASA, and we had a lot of in-kind contributions from NOAA, the GEO3 project, and many others. It was a really, sorry, we don't have much more. We should have probably talked a little bit more about FRAPPE. FRAPPE, we had in total about 5 aircraft flying around the area. We had 5 mobile vans. We had a bunch of extra ground-based measurements. We had ozone sounds. We had a lot going on here in the Front Range. Really, the main focus was to understand what are the driving sources of summertime ozone in the Colorado Front Range. And we measured a way more than just ozone. We measured a lot of the air toxic VOCs. We measured NOx in various places. We measured at the ground. We measured the full 3D all the way up into the atmosphere. So we have a really, really comprehensive data set. And I also want to say that all the data are public. So if you just Google FRAPPE Colorado and you come then eventually you find links to our data archive, and you can look at whatever measurements you like to look at. So our purpose was to use the data set from FRAPPE and Discovery Q together with long-term monitoring at monitoring sites in Fort Collins to see, are the monitors that you have here really in the good location to give you good information about what's going on in regard to ozone in the area of Fort Collins, and to what degree are people who live in Fort Collins exposed to ozone pollution. A main part of that is looking also at wind patterns. You want to know when you're at a site, where does the wind come from? Now in Fort Collins, there is 2 ozone monitors. The one is at CSU, so right in town, and the other one is at Fort Collins West, which is west of town. When we look at, and these are measurements, so do you see my pointer? Yes, you see my pointer. So here, what you see, these are wind roses. So these basically give you for Fort Collins West on the left and for Fort Collins CSU on the right side, They give you wind roses that tell you for the morning or for the daytime and for the night time from which direction the wind is coming from. And when we look at Fort Collins West, then we see that during the day we get mostly winds that come from the southeast sector, and at night the wind comes mostly from the northwest sector. And these are the typical summertime patterns in our wind patterns. During the day we have upslope flows, and at night we have somewhat downslope flows. And this Fort Collins West represents, when we look at larger scale picture, represents very well the regional wind patterns. If you look at Fort Collins CSU, we see that it's kind of shifted, specifically during daytime, and we go much more towards the south. So we are more from the south-southeast. And so that already gives us a first indication that Fort Collins CSU, there is probably some local influences. It's right in town, and when you look where the sensor is placed, there are parking garages nearby, so it's not necessarily totally representative of a larger scale picture. Interesting when we look at the diurnal cycle in ozone at these two monitoring sites, but you see that on this place, on this graph here. Fort Collins West is in red, and Fort Collins CSU is in blue. There is two interesting features that you see. The first of all is that Fort Collins West has overall higher ozone. And second of all, at nighttime, Fort Collins CSU has way lower ozone. And that's very indicative that Fort Collins CSU being right in the middle of town, so this very low ozone at nighttime tells us that there is a lot of NOx around that eats up the ozone at night. And so in the city, we have a lot of NOx, we have a little bit reduced ozone production because we have so much NOx. Yes, you need NOx for ozone production, but when you have too much, you are not producing actually too much ozone. So there is this sweet point. If you don't have enough NOx, you don't produce much ozone. If you have too much NOx, you don't produce much ozone. But if you're in the middle, then you can produce ozone efficiently. At Fort Collins West, which is west of town, that's when we actually have the higher ozone, and this is also because you bring the ozone from Fort Collins outside the city towards the west, and during the transport, you can start or keep creating ozone. And that's why we find actually west of Fort Collins higher ozone than in the city. This is a little bit a more complicated plot, and it tells us maybe the same. I think in the interest of time, maybe I skip it. These are what we call pollution roses. And we also have NOx measurements, and we also have, at Fort Collins West, we did during Frappe, we actually had NOx measurements. They are not their standard. And then we had also pollution roses for ozone here, for Fort Collins West and for CSU. And basically what you see, the red values mean always high. And so basically what you see whenever the wind at the sites comes from this upslope direction, that's when we find the highest NOx. And that makes total sense, specifically for Fort Collins West, because we bring the pollution from the city to Fort Collins West. If we look at, this is a wind analysis at Fort Collins CSU from 1990 to 2016. I'm not sure the plots are a little bit small, but basically with this plot, what we want to show is that really the upslope winds from the south and southeast dominate during all years. When you look at the graphs, what we also found is that there is actually 2 years, 2013 and 2015. I don't know what happened to the wind sensor or to the data, but these data were definitely screwed up. So you have to be really careful when you get data from data archives and you look at them. Look at them with a critical eye, because sometimes, they are up there, they might be quality controlled, but they not necessarily are 100% error-free. So in all our analyses for multi-year data, we basically just took these 2 years out, because it was just clear that there is no reason why 2 years suddenly would have very different wind patterns. We also looked at other sites in the Front Range to put Fort Collins into context to the rest of the Front Range. And we don't have for all the sites in the Front Range, data back to the 90s. So we looked only at the 2012 to 2014, 15, because for this time period we had data for all the monitoring sites. Look here at this graph. What we are showing here is, like earlier, the diurnal cycle of ozone. So ozone is typically lower at night, and then you start producing ozone during the morning. It peaks towards in the afternoon, and then starts decreasing again in the evening. So that's if you, for example, exercise early mornings, you typically don't experience much ozone pollution. If you exercise later in the afternoon, then you have a lot more ozone. So that's something how we can very easily protect ourselves of bad air. In regard to ozone, PM2.5 is trickier, but we don't have typically too many particle problems in the Front Range. So here are different sites. Blue is Fort Collins CSU, so the Fort Collins monitor in downtown Fort Collins. Red is Fort Collins West. And then we compared it to the monitor in Boulder, at NREL in Golden, at Greeley, at the Denver campsite, which is just in downtown Denver, and also Chatfield, which is south of Denver. If you look at the diurnal cycle, what we see is that the two sites, Fort Collins CSU here in blue, and the light blue, Denver Camp. So they have this, what we said earlier, very low ozone at night, and also, you know, the lowest ozone during the day from all the sites. So that is very typical for an urban regime, for a higher NOx regime, as I mentioned earlier. Versus sites such as Fort Collins West, that is in red, is amongst those with the high ozone and also with the higher ozone at night. That is indicative of a non-urban lower NOx site. What we also did for all these sites is we looked at the weekend effect. What the ozone weekend effect means is that you have higher ozone on the weekends than during the weekday. Well, that seems counterintuitive, right? Because we drive a lot more around during the week than on the weekend, so wouldn't we have more pollution? But if you're in the city, and like I said earlier, if you start having too much NOx, you are not creating that much ozone. So at an urban site where we are in this really high NOx regime, like, for example, Camp or CSU, we have so much NOx during the week that we don't create ozone as efficiently. Versus now, on the weekends, we sleep in, we don't drive to work, we have a lot less traffic going on. Now we actually have just that sweet spot of NOx that we can start producing the ozone. And so that's why at these urban sites, Camp and Fort Collins CSU, you see that we increase our ozone over the weekend. Versus if you look at the non-urban sites, you don't really see a large change between weekend and weekday. We also can look at the trend in this weekend effect. And let's maybe just focus here on the CSU side. And because for the CSU, we have ozone measurements that go back into the 90s. And we can look at the annual trend in the summertime weekend effect. No, sorry, that's not the weekend effect. Here is the weekend effect. So CSU is, again, the dark blue. And we see that actually this is the annual trend in the weekend effect. So the weekend effect is actually decreasing. It's actually less pronounced now than it was years ago. And that suggests that we actually really reduce our NOx in the city, and that weakens this change here. So, you know, if this is for 2012, 2015, if we would have done that plot for 90, something like that, it might have even been going up like that. So our weekend effect is actually getting less pronounced, suggesting that we are really decreasing our NOx concentrations in the city. And in line with that, if you look at the annual trend in the summertime ozone, then we see that since the 90s, in Fort Collins CSU, it actually has been increasing, it has been going up, which is in line with kind of getting into a more ozone production efficient regime. So, but we have to keep decreasing. If we want to get our ozone down again, we have to keep reducing NOx so that we now go over this hump and get into the low ozone production regime. Now I'll start looking at some of the data from FRAPE Discovery Q. So far we only have looked at the surface sites and looked also at multiple years. But we have from FRAPE, we have a lot of measurements available. And we have more than just ozone and NOx. But what I'm showing you here is the C-130. So our focus of the FRAPE and Discovery Q campaign was not just Fort Collins. You know, we looked at the entire Front Range, and we also looked at outside of Colorado what comes into the state, et cetera, et cetera. But we also had quite a few overflights over the Fort Collins area. And so these I'm showing you here, and I'm not sure if you can see, so Fort Collins, LaPorte is even indicated here. So see. And these are the overflights over this of the C-130. We only look at data that are close to the ground, about less than 1 kilometer above ground level, and just plot all the aircraft data on top that we have. These are 10-second data. NOx on the left side and ethane on the right side. Ethane is a pretty inert volatile organic compound, but it's a very, very good tracer for oil and gas sources because it most exclusively comes out from just oil and gas sources. And when we look at that, what we see is that really the highest NOx and specifically also the highest ethane concentration during these overflights with the aircraft, we find on the eastern side of Fort Collins. And you know, we have to keep in mind here, these are only daytime data, but they are on very different days and they are just individual samples. But also Frank will show later on also the model results, this is also pretty much in line what we see from the model during all times of the day. And that's also really in line with the wind direction, that during the day we have mostly the upslope flows. And like Cassie has shown earlier, the figure of all the oil and gas wells that are just to our east here in Fort Collins. And so it makes total sense that, you know, we get the highest ethane from that direction, and then it starts diluting and decreasing when we go further west. So we have done a lot of having all these wonderful data. They allow us really to evaluate our models and create all the inputs for our models and design our models so that we can get the highest confidence in them, so that we can actually really use them to analyze and look at various emission scenarios. So for this study here, we have been using the WRF CMAQ model. This is an EPA-approved model. It's used in a lot of SIP modeling. It's not used, CMAQ is not used for the state of Colorado SIP modeling. That's being done with CMAQ, but pretty much in most other areas, or in many other areas, it's done with CMAQ. Our simulation for this air quality model includes 2 domains. So we have an outer domain that is a 12 by 12 kilometer that covers most of the western US. And then we have an inner domain over Colorado that we run at 4 by 4 kilometers. During the time when we started our study, there was no emission inventory for 2014 available. That's often the problem, that emission inventories lag in time. So the 2014 emission inventory actually just became available for modeling, I think 6 weeks ago or something like that, and that's V1, and V2 is still in preparation and should be available soon. So you're always a little bit behind the time if you really want to work with emissions. Now, we did the best what we could, and there should have been actually some colors on here, but obviously not. So what we did is CDPHE and Alpine Geophysics helped us to get the most representative emissions together for 2014. For oil and gas sources, we were able to get 2014 activity data that we could process to get emissions, and also for the EGUs, so electric generation, like power plants, etc., we could get the 2014 activity data. For all the other ones, we were taking 2017 projected emissions, which should have been way better than the only other available inventory that was available to us was 2011. So we really did the best of the best to put together our what we call a priori emission inventory. So something that we got from data that are out there, and we tried to put together our emission inventory. This is how the emissions look, and so these here are the NOx emissions, and these here are the ethane emissions, and overplot over these maps of these squares with the emissions is the plots that I had earlier from the concentrations of the aircraft. If you look at the NOx, there is a pretty good resemblance between the NOx emission spatial pattern actually and the underlying emissions, and you see clearly, you know, downtown Fort Collins has the highest NOx emissions. For ethane, it's kind of, there is a total mismatch. Why do we have all these boxes also over Fort Collins and everything? Well, the thing is, if you look at the scale here, it goes to 2 times 10 to the minus 2, our emissions, versus the emissions in Weld County are up to 100, a factor of 100 higher, actually. So the point is that on this color scale here, if I would plot that on the color scale, to also show Weld County emissions, I wouldn't see anything anymore. So the emissions of ethane in the Fort Collins area are just tiny. So whatever ethane concentrations we get here, or specific oil and gas VOCs, that comes through transport. That's really not coming from our own area here. We did a lot of work, so we put together our emissions, we can look at our emissions, and if you wouldn't have field campaign data, what do you have? You have typically a few ozone monitoring sites. If you're lucky, some more or less good NOx measurements, and then you need a lot of good luck to hope that your emission inventory is correct. Now, when we have the aircraft data, then we can do more than just luck, because we have all these VOCs, we have NOx from the aircraft, we have a lot of measurements that we can use to look at how good is our emission inventory. And we don't need to go into the details, and it's all described in the report to the state of Colorado, actually. That's also linked to in the report for Fort Collins. But basically what we used is we used the aircraft data. We did a very careful filtering so we use the aircraft data. We run our model with our first emission guess, and then we compare our model to the aircraft data. But we do a very careful filtering, because what if our model gets the winds wrong? Then I compare an apple and an orange. The model might get something from the oil and gas, and in reality, the aircraft sniffed something totally different. So we make a very careful quality filtering of, we only use data when the model and the measurements were from within the same wind direction. And we also look at the emission contribution in these individual aircraft samples and say, well, that aircraft sample was mostly dominated by mobile sources. We only evaluate that to look at the mobile emissions, versus that sample was mostly dominated by oil and gas sources. Well, we only use that to evaluate the oil and gas sector, because it was shown that these two sectors have the majority of the emissions, and these two sectors we were able, with our aircraft data, to constrain. Now, if we do that, and we did that for 3 different regions also, because there is rather chemically, there are different regimes between the non-Denver urban to the northwest of Denver, the Denver area itself, and also the oil and gas region, mostly Weld County. We look not only at absolute concentrations, we also compare emission ratios. We spent a lot of time to say that how good are the emissions that we put together, and are they good enough, or do we need to do something to them? And what we find out is, if we do all that, is that here is again the table from before with the a priori emissions. Yeah, it's a little bit messed up, the slides here. And when we look what we had to do to the mobile sector and the oil and gas sector, the mobile sector, there is one trace gas in the one emission species that's ethane. It's chemically not that important, but it's a very good tracer for mobile sources, and that just was underestimated pretty much in the emission inventories, all across the Front Range. There is something strange in the speciation profile obviously going on or whatever, so this had to be increased. The other interesting thing that we found is that in Denver, we seem to be doing pretty well with the mobile emission projections for 2017. But when we went outside of Denver, so in the non-Denver urban area, like including Fort Collins, but also Weld County, it seems that the traffic is underestimated by about a factor of 2. So in these 2 areas, we had to double the 2017 mobile emission projections in order to get a better agreement between our model and our observations. The oil and gas emission inventory, we had to double pretty much what was coming out of the emission inventory. Only ethane. Ethane was again a little bit like the S sign for the mobile emissions. That was a little bit out of line with all the other VOCs. But all the other VOCs, benzene, propane, whatever else, the high alkanes, we had to double in order to get a better agreement. And this is actually a conservative estimate. The underestimate was in parts more, we could have also justified an increase by a factor of 4, but we decided we go with the more conservative estimate of a factor of 2. How did this, what we now call this improved emission inventory, compare with emission inventories that are out there from EPA? That's what you see here. So in yellow is our first gas emissions, this a priori emission inventory. In red is what we derived and said that's our improved inventory, which we call the posteriori. And then we compare this to emission estimates. NEI puts every three years, it puts out an emission inventory. There was one from 2011, then just recently 2014 came out, and then there is EPA 2017 is the projected emissions for 2017, because the actual EPA 2017 won't probably be coming out until 2020 or something like that. So we compare that to these. So if we look at our a priori estimates, the yellow ones are pretty much on the low end of all the emission inventories, also compared to the other EPAs. Maybe just in NOx a little bit higher than the EPA 2017 projections. Our posteriori, so our red one, is it's a little bit higher, less than 2011 in the NOx, and slightly less than also the 2011 in the VOCs. But if you compare it to the year that it should be compared to, which is actually EPA 2014, we see that in NOx we are higher, and in the VOCs we are quite a bit higher. So that tells me already now that probably if I now use my EPA 2014 in my model, if now the model files for EPA 2014 are available, I might also not have all the VOCs that really should be in there. And we also show you here this table, just as your interest, and highlight Larimer County and see how these emissions compare basically to the other counties in the Front Range. So what you see here in NOx, it's actually, there's quite a bit of NOx coming out from the, also in Larimer County, but what's really sticking out is actually Weld County with a lot of NOx, and specifically if you look at the VOCs, it's kind of compared to the 150,000 tons a year that come out from Weld County. There's really very little coming out from all the other sources in the Front Range. So just to give you a little bit of a feeling for how the Front Range emissions vary in between the different counties. So basically, with having the most confidence in our red bars here in our posteriori emissions, we kept basically running our model. But like I said, winds are very important. We want to know, is our model doing a good job in the metrology and in the transport, so that we know that it really transports the right emissions into Fort Collins before we look at the ozone in Fort Collins. So what I'm showing you here is for daytime again and nighttime, and like you've seen earlier, the wind roses. Top row are the observations, bottom row, CMAG. And you see, these are the two wind roses for Fort Collins West during daytime, and the model gets the wind direction actually fairly well. I'm not sure if anybody of you are modelers here, but to me as a modeler, it's kind of, oh wow, that's perfect. You also have to really keep in mind that we are talking here about a 4 by 4 kilometer model grid, and that we have a monitor that's sitting at one spot there. But Fort Collins West is, there isn't too many buildings around. It's a good site to give you a rather more regional, larger scale picture. At CSU, what you see is that the model says, it looks pretty similar to Fort Collins West because the winds in that region just come from the southeast. Versus really the measurements like we've seen earlier come a little bit more from the south. And that just tells us really that, there might be at CSU, there might be channeling because there are nearby buildings or roadways, and that just influences your local wind patterns, and that will also influence your trace gases to some degree. We also can compare the model with the average diurnal cycle in ozone on the top, in NOx for Fort Collins West, and in CO for Fort Collins CSU. And I would say in ozone we are doing actually a fairly good job. The model does obviously seems to not get quite this high NOx quite as right at CSU, which could very well be also that there is nearby maybe a NOx source that in our model in the 4 by 4 kilometer grid box gets a little bit smoothed out. Could be also because of the not capturing exactly this localized wind. We could maybe not transport the right NOx to that site. But at Fort Collins West, the model is pretty much right on. Interesting when we look at NOx and CO, well, we are not really doing that well. We do get the diurnal cycle, sort of. We get the rush hour peaks and everything, but we don't really get the concentrations very well. Now you have to keep in mind there is one thing, we are looking at a 4x4 kilometer grid box, and also to compare my model to the observations, I take the grid box that includes the location of the measurement site. For Fort Collins West, the problem is that the measurement site for Collins West is actually just at the edge of this one grid box that I'm looking at here. Now what happens if I look to one grid box that's just to the west of it? That's, well, you know, the location is just scratching on, basically. You see, then suddenly my NOx agrees well better. And that's just a grid box that's one west of it. So you really have to be very careful. It's kind of, this just demonstrates you, we have a 4x4 kilometer grid box, and we have a localized measurement at one site. So we have to be a little bit careful and have to just not blindly look at, you know, a direct comparison and say that, you know, I match it with that grid box and that's it. You have to always keep a little bit your eyes around. But overall, so we are doing a fairly good job at capturing the characteristics. We also can look a lot more at the aircraft data. And just a quick view, this shows here C-130 NOx data. Again, on the top NOx, on the bottom we show CMAC. And then what we filter it by the measured wind direction. So we look whenever the C-130 measured that the winds are from the north, how do our NOx measurements look when the wind comes from the east and when the wind comes from the south. And we didn't have too many flights where the winds were from the north. That's also because during daytime, that's typically not the dominant wind direction. But what you can see is whenever we have the wind from the north, we actually had way lower NOx than when we have the wind from the east or the south. And if I look at the same at the ethane, it becomes quite clear, well, when do we get typically our, you know, oil and gas emissions? Not when the wind comes from the north. We get it when the wind comes from the east or from the south. And the ozone is a more tricky business because, like we learned, ozone is not directly emitted, it's produced during transport. But even here we can see that on the days with the winds, and this is now not filtered by wind direction, but it's basically, we see that really on the east side we have more ozone, but as I said, that's also, with the ozone, a little bit more tricky here. And given that, I think we'll keep now playing some model scenarios, and Frank will take over with that.
It's time to let the observation guy talk about models. What I like about this picture here is that you see the arrows and all the red and orange dots, and this is, you know, where your high ozone comes from. So you can draw your own conclusions about that. I think it's pretty obvious what's going on here. So now, what we did with, so Gabi told you how we optimized the emissions that went into our modeling. So now when you get to the point where you say that your emission inventory that you put into the model is as close to correct as you can get it by comparing it to the observations, then you can start playing games with the model. Then you can say, okay, what if we turned all the emissions that are attributable to people, all anthropogenic emissions, what if we turn them off? What would happen to the ozone? And so this is what this is. This is a plot of the average MDA8 ozone value. This is the 8-hour average value. That is what EPA uses to put places into compliance or out of compliance for the Front Range area. And we are up here. This is, I don't know which one this is. This is probably Fort Collins downtown. I think Fort Collins West would be more here in this region.
I think it's big enough.
Yeah. So yeah. So this is where we are. So we, you know, this is the kind of the distribution of the high ozone, and this is partially a result of this transport to the west that we talked about. Here's the Continental Divide. You can see the Boulder County's border, and that goes along here. So you can get this all the way into the mountains. So this is where our high ozone is. And so what we'll do now is we'll turn off all anthropogenic emissions and look at the difference. So how much less ozone you would get if you did that. So this is the same graph, and you can see that where all the high ozone is, is this where it goes away when you turn the anthropogenic emissions off. So that makes sense. All right, so you have the highest ozone reduction where you have the highest MDA8 values. And that ozone reduction is somewhere, between 15 to 25 parts per billion. So that is the ozone that we produce here in the Front Range on top of the ozone that comes in from elsewhere. Okay, so the average ozone that we are getting here from other states and global contributions and all that is about 50 ppb, and then we'll make this 15 to 25 ppb on average on top of that for 8-hour averages. There can be a lot more ozone in the 1-hour average, can be a lot more ozone on specific days, but this is averaged over the whole frappe period. So we can play more games now. We can say, well, what if we only turn the oil and gas off, or what if we only turn the cars off? And what if we only turn the industry off? And what if we only turn the CEM contribution? CEM means continuous emission monitoring. So power plants have that. They have emission monitors in their stacks, and they're constantly reporting that. So this is what happens when we do that. So when you turn the oil and gas contribution off, you see that the average ozone reduction, and this is on average for the MDA8, is pretty impressive. It's somewhere between 4 and 6 parts per billion in the northern area, kind of mostly north of 40 degrees north, and we all know why that is. And if we all stop driving, we could have the same effect, but it would be differently distributed, spatially differently distributed. It's where most people drive. So you can see that you can get this reduction here, right? But it's downwind of where most of the traffic is. I-25 runs about here. Most people will drive here. You see the effect is here. And that's because during the daytime you have this east to west transport. And it takes a little bit for that NOx and for those hydrocarbons that come out of the cars to kick in and make ozone. So it's a little bit shifted. Just like this is also a little bit shifted west from where most of the oil and gas wells are, which are roughly in this area here. So you see that transport there. The industrial contribution is not very large. We were actually kind of surprised by that. And it's concentrated around the area where most of the industry is in Commerce City. It's out between Denver and DIA in that area here. And you can see a few points actually where this goes the other way around. So DIA is actually classified as an industrial emission, even though it's a transportation hub, but it is what it is. And here you actually get a negative effect because the main emission from DIA is NOx. So when you turn that off, you get more ozone because you don't have titration. That's kind of similar to that weekend effect that Gabi was talking about earlier. And similarly, you can see this when you turn the power plants off. You actually get a little bit more ozone there, but you still have an effect downwind of it. And I don't know why this doesn't show up here, but we had this, downwind of it, you see a little bit of an ozone benefit when you turn it off. And the same was true for CMs. I'm not sure why that is in this plot here. So this is the same grid again that Gabi was showing earlier that is centered over Fort Collins. Here are the two sites, Fort Collins West and Fort Collins Downtown. And so here again, this is the base case ozone. These are now actual values, okay? So this is not the savings that you get when you turn things off. So it's a little bit the other way around. It's a little bit harder to read. But what you can see is that the background is somewhere in the high 40s, okay? So this is with all the anthropogenic emissions turned off. That's what ozone would be here in our area. Turning off the power plants doesn't do much for Fort Collins. That's because the only power plant you have is up here somewhere. And then there's one way out here by Brush, but that really doesn't affect you much. Turning off the industrial emissions doesn't do much for you either because you don't have a lot of industry here. You have a large brewery. That's some VOC emissions out of that and some NOx emissions, but they also have lots of solar panels on their roof and stuff, so I think they're doing pretty well. And the two big contributors here are the mobile emissions and oil and gas emissions. You can see when you turn either one of those off, you get the highest impact on the ozone. It kind of gets more mellow across the area. So you probably with either of those sectors, you probably would be in compliance if you were able to turn them off completely. So now, we also do something else. We don't use the 3D model. We just look at the chemistry. So And that's good for me because I'm kind of the chemist guy. I'm not really the modeler. That's the thing that I like to do after doing measurements. I take it simple. So I use measurements that it's a model, but not really. It's just, like the 3D modelers laugh at me about this. They're like, oh, man, this is not a model. This is, So what we do is, we use actual samples that we measured on the aircraft, and we look at their ozone production potential. So we say, okay, this mix of air, how much ozone can this make? And so the way we do that is we stick that in a jar and shine the sun on it. And don't dilute it, don't transport around, do anything bad with it, don't put any emissions into it. We just put it in a jar and say, how much ozone can we make out of this? Okay? And we do this in two ways, and I don't really want to get into the details here. We can talk about this later if somebody was really interested. But we do this in two different ways, and it gives you an idea on regionally how the ozone production potential varies with those samples. Oh, that feels like our lab. We are right next to railroad tracks too. So it happens about once an hour. So now, what we do here, and maybe but I'm just going to let you look at this one here. Okay, so those are the different sectors, wind sectors, from which air can come into the city, compared to one another, if you were to put them in a jar and let them react for 8 hours. And how much ozone you would make on top of the ozone that you started with. So these are all, they all start at 60 parts per billion. And what you can actually see is that the northeast sector, which is where most of the oil and gas is the most reactive. That mix is the most reactive. So you can make the most ozone out of that. The southeast sector is also where most of the oil and gas is also very reactive. You can make a lot of ozone out of that. The south central sector, this sector here, samples that were taken here, is also still relatively so more in the southern part of the city, you have a little bit more reactive air, whereas once you get over to the southwest sector here, the red, and the northwest sector here, the brown, you get into the point where the air is either already kind of reacted away a little bit because it took a while to be transported here and there are no new emissions coming into it, or you got some air that was maybe even downsloping from the mountains that had lower reactivity. But this is really where your reactivity is. It's on the east side of town, and that's a problem. If you live west of there, you're going to get the product of that chemistry that is coming to you during that time. So this is a similar exercise. But those numbers are the ozone production rate in parts per billion per hour on average in a sample that was taken in various places. And so we split up the area a little bit into Pawnee, Northeast Weld, and East Weld County. Pawnee is kind of the northernmost one. Northeast Weld is a little bit lower than that. East Weld is Eastern Weld County. Then Fort Collins Loveland is essentially the box that is over Fort Collins and Loveland. Greeley is special because we just picked out the town. This is a big source of nitrogen oxides in the sea of hydrocarbon emissions. Then as a comparison, I put the West Denver Metro in there. So this is like Lakewood and those places that have the transport across the Denver area and get this air. So, and then again, this is the sample unadulterated, the one on the right, the big number. And then those other numbers here are when these sectors have been removed from that sample. So what we do is we use the relative emissions and we reduce all those hydrocarbons and all the NOx that is in that sample that we can attribute to those emissions. We take those out and then we run the sample again and look at how much ozone it does if you do that. And so you can see that all the Weld County ones, surprise, surprise, if you take the oil and gas emissions out, there's no more ozone produced in those. Pretty much negligible ozone production in there. That's not surprising because there aren't really all that many other sources out there. Now in Fort Collins, you can see that about half of the ozone here is attributable to mobile emissions. If you turn the oil and gas off, you get about the same reduction in there. And Greeley is similar. You can turn the oil and gas off, and you turn the mobile off, you get a slight reduction there. But Greeley is a special case. We don't really want to get into that. It's a kind of a tricky place. But the West Denver Metro, you can see, there's also mobile and industrial emissions here, because the oil and gas doesn't very often make it all the way to the south there. You can see that here the mobile emissions also are considerable reduction, kind of similar to Fort Collins, Loveland. And then the industrial emissions are also considerable reduction. So we can play games like this, and we can look at all the different sectors on the Front Range and see which type of emissions are the most influential. And we can do this for a whole bunch of samples. This is as a comparison for Commerce City, where the largest reduction is again industrial, and the Denver City, where mobile and industrial emissions dominate. So I don't want to get into this a little bit. I'm sure you have a ton of questions, but the question that Fort Collins asked us is where should we have our ozone monitors, and what else should we look at in order to see what's coming into the city, and and how things are changing with maybe oil and gas regulations being implemented, and maybe the vehicle fleet becoming cleaner over time. How can we keep track of that, and how can we relate that to our ozone? And so we think that a meteorological sensor at Fort Collins West, winds and temperature, would be a really good idea if we had that continuously. We only had this during the Frappe campaign, and we learned a lot from looking at those winds. So it would be great if we had those year-round. The CSU site is in the middle of the city, so that is always a problem, because you have parking lots there, you have large NOx emissions that temporarily reduce ozone. I actually don't think that the ozone production in Fort Collins is lower than Fort Collins West. I think it's mostly titration. I really do think that it's because there's a parking lot, the road is right there, and you have all these NO emissions, and they really mess you up if you don't know what the NOx is. So having a NOx sensor at CSU would really help, because then what you can do is you can add the NO2 and the ozone together, and that is a conserved quantity, and then you can look at that. Because when you react ozone with NO, you get NO2. And then that NO2 fertilizes and makes ozone back. So if you add the two together, you have a conserved number, and you really learn a lot from that. So that would be an excellent thing to do, this NOx sensor in the city. Now, the FC CSU site might not be ideal, but you have 20 years of history there. So you really don't want to move that sensor, probably. Just, add NOx to it, and you're golden. But you're also poor, probably. That's the other thing. And then the other issue is you don't have anything on the east side of town. And if we were to place one sensor on the east side of town, we would put it on the southeast end, because there are times when you get pollution from the Denver area up here, that when there's a strong southeasterly component in those upslope winds, and it would be better captured if you had a sensor in the southeast. And that sensor should have ozone meteorology, because you need to know what the wind direction is. Just measuring ozone without knowing what the wind direction is only a half-baked deal. And if you were to do VOC measurements maybe once a day, that would be really good. I can't give you the money for it, but we can sure do the measurements. I can tell you how to do it. So that's the final slide, and we open it up for questions, and for Gabi and myself if you do have.
Just to get a feel, show of hands, how many people have questions? Okay, that's not overwhelming. 3 or 4. So
Yeah,
we will
should be able to
do
do
that. I'll start in the front and work my way back.
Okay. That is correct.
Yes.
Well,
Well, okay, it doesn't have to be, but for ozone, because it is a secondary pollutant, because it doesn't come out right from the emission source. For PM 2.5, it would be a different story. PM 2.5 has a large contribution of direct emissions. It also has a secondary production, and in some areas that can be pretty significant also, but general rule, PM 2.5 is highest near the emission source. NOx is highest near the emission source. But right, and that's a very, very important message to take away, I believe.
However,
So the message we're talking about, we got to have microphones for our recording.
so if you want to live in a place with low ozone, your best bet is to live in the median of I-25. Okay? But that's not necessarily a healthy place to be, but this, the tricky thing with ozone is that is that equilibrium with NO, that it reacts with NO and makes NO2 and temporarily goes down near emissions. And the other thing is that it takes a while to make ozone. Now, our area here is somewhat special because we have those upslope-driven winds. If you live in a place where you have, let's say you have a high-pressure system in the middle of the summer, there's no wind at all. Well, then you will still have low ozone in the morning, but in the afternoon you'll have really high ozone. So our area here is a little bit untypical for, compared to large other urban centers, something like Chicago and Houston, for example, has this issue where the emissions in the morning go out over the ocean and in the afternoon they come back with the sea breeze. And then they get their own high ozone that has cooked over the water for a while, they get it back into the city. So it's a little bit special for this area that, yes, in the western suburbs, you can have more ozone than in Denver on average because of that chemistry effect. It delays things a little bit and also this titration effect that you have.
Yes.
But, breathing 50 parts per billion of NO2 is not particularly healthy either. Oh yeah, I mean, but see, so you have, if you were to stop driving, okay, if a lot of people were to stop driving, switch to electric cars or ride their bicycles or whatever, that would also reduce the demand for fossil fuels, which would reduce the oil and gas exploration in Weld County. So, what you do has a local effect and it also has a regional effect. And what we do as a community, as far as people living in the, a lot of people now live east of I-25 because everything west of I-25 is either full or too expensive. And those people will commute. If you give them an alternative to, not drive their cars, that would help the people in Fort Collins. It would also help them, because that will reduce demands for energy consumption and so on. So you cannot really say that, well, since I'm not really contributing to the ozone that I'm breathing here, I might as well keep driving. Well, that's not really a good conclusion there for that, if that's what you meant.
And you do, the thing is that there's definitely the sources in Fort Collins also contribute to the ozone. It's just that, they are only one part of the puzzle.
Then you breathe it when you visit Rocky Mountain National Park.
Yes.
Okay,
And we had days when we measured 90 ppb at Long's Peak, so it's not that.
Okay, so bear with me in the microphone thing as we do this, but I'm going to hand these over.
Yeah, so I had two quick questions. The first one was about the monitoring site at CSU. I know you put up a bunch of boxes, I think it was 20 years worth of wind measurements. Was that for the CSU site or for the one in West Fort
Yes,
Collins?
that's correct. Fort Collins West does not have continuous wind measurements.
Okay,
Fort
all right.
Collins West only had the wind measurements during Frappe that
Okay.
we took, so there
I
is
just
no
didn't
other-
know if any building or any construction at CSU had gone on over that 20-year period that you would notice in the...
Most likely, but I'm not
Yeah.
familiar with what CSU has built, but I'm
Yeah,
sure
and,
there
and
has
I
been.
have to look also at the report, and I know that there was one year where we found, I think it was in 2013 or whatever, that the wind sensor was also moved or something. And
Yeah.
I would be surprised if between 1990 and now there hasn't been any construction.
Okay.
So
I was
it's-
just curious
it's-
how consistent, you said there's 20-year history there, but if there's been a lot of construction, it may not be any different than moving the sensor around.
Yeah, to some extent that's true. You still, the thing is with if you have an ozone sensor in the middle of a city close to strong emissions of nitrogen oxides, you really want to measure nitrogen oxides as well.
Okay.
So yeah, it may not be a big deal to move that sensor to the southeast if you can't afford to add a third one. If I had to choose between that, I would probably move it.
Okay. And that leads to my second question. You said you can't give us the money to do what you're recommending, but do you have a cost estimate for how much it would take to implement all of your recommendations?
If I were to guess, if you had to construct, it kind of depends a little bit. We looked at some of the places with Cassie. There's might be power at one of the lakes down there in the southeast. I forgot it was some park or something. We talked about this. Yeah, right. If you have to build a shed and run power there, put internet in, things like that, you're probably looking at $500,000. I mean, that's not a lot of money, really. In the grand scheme of things, it's not a disastrous amount of money, but it has to be appropriated one way or another, obviously.
My question would be, I live down north, 6 square miles, LaPorte.
Uh-huh.
And my question would be, lime hydrators and aggregate processing heavy industrial facilities, do they contribute to pollution in the ozone sense?
Those places are mostly polluting in a particle sense. They need heat sources, obviously, and I know one of the Cemex plant that up in Lyons is also a processing facility like that. And as far as I know, they burn car tires. They got a permit to burn car tires in there. And it all depends on how you filter your exhaust gases. You can filter the exhaust gases and get many of the particles out. It kind of really depends on how those places are permitted and what they do. But I think that those type of facilities are more a source of particulates than they are a source of ozone. They may even put out enough NOx that when you are directly in the plume, your ozone is zero, for temporarily even, for a time. But I'm sure these are in the emission inventory, and I could look, but out of the top of my head, I can't tell you what those emissions are. But that's probably a reasonable guess. Sure.
Okay, thanks. So Fort Collins is in the same attainment, non-attainment measurement area as Metro Denver, right? So if we actually get attainment, but Metro Denver doesn't, we're still non-attainment for ozone.
No, not necessarily.
Well,
No. The attainment area is defined on the area. If you reach attainment, then your county will be out of the non-attainment area. It goes.
we
It
are
can
considered-
change. For example, not even all of Weld County is at the moment in the non-attainment area. The line for the non-attainment area goes through Weld County.
That's Eastern Weld County.
So it's all based also on SIP modeling and monitoring.
so the fact that we have two monitors is enough that those can be considered separate from Metro Denver. Is what you're telling me. 'Cause that's-
Yeah.
that wasn't
So
what I understood.
if you would really reach attainment with both your monitors, you could probably claim, most likely you can claim attainment. But I'm not a lawyer. But the thing is, the non-attainment area is not this is the area, and if there's now Chatfield violating, Fort Collins is still non-attainment area. That's not the case.
Okay, I want to come back. Did you have a follow-up? I'm sorry.
I guess our concern is the proximity of the lime hydrating plant and the constant 24-hour exposure of homes. The homes they abut. They're by the border of these facilities. And if we're worried about pollution from cars, these people that live close to the facility, a stone's throw away, literally, are exposed 24/7, including children. And from the National Institutes of Health, no studies have been conducted to determine the safety of exposure of
So, what I can suggest to you is to contact CDPHE, the Colorado Department for Public Health and Environment. They actually have a mobile measurement unit that will, if you complain about odors or any sort of health issues, they will come out to your area and make measurements. So that is a distinct possibility. So I would say that is probably your best bet.
All right. Okay, let's do one more, and then we're going to move on to our third presenter.
Hi, Frank. Hi, Gabby.
How's it going?
Hey, Tom.
Good. How are you doing? So I came in just a couple minutes late. I just wondered if you could comment on the relative, completeness of the inventories that you did the source apportionment for with the sensitivity, whether you found any problems with inventories being too low or too high, since you broke them out that way?
Yeah, we did.
This basically.
we adjusted the emissions that we had to start with, and that's the same emissions that are used for the modeling that the state does, and that they're actually
So-
required to do their modeling with that, because that's what EPA, the rule structure says. Using those emissions, we compared those to our measurements and found inconsistencies that made us adjust them in mostly the oil and gas emissions and the mobile emissions in the northern part of the Front Range. We are still not quite sure why the mobile emissions in this area are so underestimated. It's a little bit strange. You'd think that
we have to be careful because our inventory was for the mobile sector. We had the 2017 projections from Alpine
It's
Geophysics.
still weird that they are okay in Denver and not
But-
up here. That that's to me that's
It is.
strange.
It is weird, but
So we had inconsistencies there, and we did the best we could so that we could do our modeling games, right? I mean, we need to have the emissions correct to be able to turn off the right sectors and get the right answers.
All right, we've got one more. I told you you're off the hook, but one more.
Frank and Gabby, that was such a great talk. I finally think I'm understanding it after a few times of Gordon Pierce and others at CDPHE trying to explain this frappe study to me. Just a couple of questions that I had is, do you know why the emissions inventories for the oil and gas is being underestimated, other than reporting is being underestimated?
there is, to some degree, it's leaks. To the other, it's also what we, for example, we have also mobile canister samples of VOCs right next to different sources. And there were various sources that, like wastewater facilities, that obviously did not seem to be in the inventory, but that put out a lot of, they are just small, but they still put out quite a bit of VOCs. And so it might be a combination of various factors like that. And our study is not the first one who finds that the oil and gas emissions seem to be on the low end.
Thanks. And then one other quick question is, this is the perfect slide I was going to ask about. Are these the modeled estimates after you adjusted for the emission inventory? Is that, or did you just say this and I didn't even?
Yes, so the priori emissions.
Oh, there we go.
Yes.
Okay.
So the priori emissions are the ones that we put together from activity data and whatever best inputs that we could get. And the posteriori are the ones that we then updated from the priori based on the comparison with the aircraft data and also other data.
What months did you do your flyovers and the airplane stuff?
Mid of July to mid of August.
Great, thank you. All right, let's move on. I want to make sure we have time. I assume you all are sticking around to the end. Okay. All right. So next up, Tammy McMullen.
Well, thanks, Frank, because you introduced our mobile lab at CDPHE, and that's what I'm going to talk about. So thanks for the introduction and setting that up for me, even though you didn't know that. So they've made a really good kind of basis of understanding maybe now why you might be interested in understanding what we're doing at CDPHE regarding responding to people's health effects and people's health concerns that live near oil and gas. So my name's Tammy McMullen. I run the Oil and Gas Health Information and Response Program. I am on the health side of the Department of Public Health. We also have our environmental division, where our air quality scientists and others that work with Frank and Gabby probably quite regularly, where they work and they really do a lot of the assessments and regional air monitoring. So I am not from that side, although this program is a collaboration of our two groups together to really understand what are the local impacts to people living near oil and gas. So I just want to make that clear because, CDPHE is a big place, right? And the divisions, while we do talk, we have different sets of expertise that we're trying to understand. So I am not a regional air quality expert. I am a toxicologist and risk assessor. So if you have air quality questions, refer them either to Gabby or Frank, or I can take them back to my staff at CDPHE. So, but it all relates, as Frank had stated, that the regional air quality impacts local air quality and vice versa. So, Okay, so a little bit about our program and how it relates to oil and gas. Back in 2014, Governor Hickenlooper put together an oil and gas task force. So in part of the final report of that task force, they stated that a lot of citizens expressed concern about potential health risks associated with exposure from emissions to oil and gas activities. And so the task force stated that they believe that citizens deserve and need accurate, credible, peer-reviewed scientific information to help them evaluate risk. So that's where our program came about. We were funded back in July of 2015 to start the program at the Department of Public Health, and really with two main objectives. One is that we would evaluate the scientific evidence around health effects of living near oil and gas. So not evaluating necessarily regional air quality or other aspects of that, but continue to do monitoring and evaluation of the scientific information around that and what kind of health outcomes can happen by living near oil and gas. And then the other objective of our program was tracking and investigating health concerns throughout the state. Prior to our program starting, citizens felt frustrated that they might call the Oil and Gas Commission, they might call the local county, they might call the Colorado Department of Public Health, but they never really got a good answer around their health concerns. And there wasn't just a centralized place where we were collecting these type of data on health effects. So again, I just wanted to state, I'm kind of narrowing in on thinking about local air quality, okay? What kind of health effects might be happening from, a woman kind of said, what about benzene next to a school or something like that? So while we're interested in ozone and clearly understanding that that can also impact health, one of the things we want to understand are what kind of volatile chemicals are being emitted from oil and gas and that are local, right, to people that live really close to these areas. And then, so what kind of chemicals are being released? How much of them are being released, right? And are those levels at levels that might be harmful to people's health? So that's a big question, and a lot of things we're trying to answer. So first of all, what we did in our program again was to step back and say, okay, how do we, how do we look at all the existing science? What does the existing science say throughout the nation, but also kind of worldwide around health effects? And unfortunately, there's not a lot of epidemiological studies or studies that look at associations between people living near oil and gas and the health effects. We've had some done by investigators at CU Health Sciences Center, McKinsey and others, but those have been some of the few that have actually been done. So that's part of what we did as an evaluation of the scientific evidence. So we also wanted to also provide health information by going out and doing community air sampling investigations. And then we provide a clearinghouse of information to citizens on our website. And also a hotline that citizens can call. Oh, you know what? I've got that on the next one. Good question. Okay, so on our website, there's the report that we put together of evaluating the existing science. I'm not going to go into detail on that tonight because I wanted to really talk just more about what our investigations are finding and just give you a broad picture of what our program does. But it's available online, and you're always welcome to give us a call, too, if you have any other kinds of questions on that. Here's the hotline number. And, I forgot to bring cards. But I think you
I
might have some,
upstairs,
Cassie.
actually.
Okay,
I can go
great. Okay, so if you can go back real quick.
Oh, sorry.
There you go. Okay. So we have a hotline you can call that actually is through Colorado Help. So there's somebody manned on that. And we also then, you can report something relatively easy if you just report your health concern here. And so myself or someone on my staff call usually within the same day, but we give ourselves 1 to 2 business days. So we want to be responsive to people when they've got health concerns or they're experiencing symptoms that we address it pretty quickly. So I'm going to go into that. Good question. We're trying. So one of the things we're doing is tracking the concerns. This is also on our website. Right now, we've had, since fall of 2015 when we started, we've had about 400 people call with concerns. The majority of them, of course, are from Weld County area, not surprisingly, since that's where the majority of oil and gas is right now and the activity happening. About 70% of those people actually report true like health symptoms to us. The rest are just questions, or they're concerned about development coming in their area. And so we try to answer their questions. So that's one thing that we do, kind of what you asked specifically. So if people just have questions, our intent is to be a one-stop shop where we can get those questions answered for people. If it means we have to go to the Oil and Gas Commission or our local partners or whatever, we're trying truly at the state to make it simple for people. That might not sound like that could really happen, but that's what we're doing. This is what people are reporting so far. Primarily what we're seeing are the people that live near oil and gas report symptoms like eye, nose, throat irritation, nausea. So neurological primarily would be nausea, headaches. People are reporting difficulty breathing, and those are really the primary ones. Okay, so this is what we generally do in situations where we're getting, say, for example, a cluster of lots of concerns coming into an area. So our intent is to ensure that we can get somebody out there. I have someone on my staff who just does site visits and responds to these calls. So we go where the people are reporting the concerns, number one. We want to get out there in the field and understand it. We talk to the local governments. We also talk to the Oil and Gas Commission and to our air quality division, because they also have oil and gas inspectors that go out and inspect sites. So first of all, we want to get out there and understand what's happening in the community. I should back up too. When somebody calls us, we're logging all of that into the database, including all of the demographics, all of the health symptoms that are categorized. So all of that information can be extracted, and hopefully over time, when we get enough information, can be analyzed in a way. It's the first database that's ever been collected in the entire nation around health symptoms that people are experiencing with oil and gas. So would you go back one more, Cassie? Sorry. Okay, so site visits. Again, we work with the regulatory agencies, operators, local government, stuff like that. But one thing we've realized up front is it was really critical to have people other than myself, who are not oil and gas experts, on my team. Because somebody with oil and gas operations expertise on our team is essential to be able to kind of talk that language and understand maybe what the operations are going on that site, to work with inspectors, and to just ensure that what we're doing is, accurately kind of addressing those situations. All right, so when we go out and do site investigations, we usually do a couple of things. Primarily, of course, we're concerned about air. We really don't get a lot of calls around concerns with water contamination in Colorado. It used to be talked about a lot for water pollution and all of that, but I think primarily because a lot of people are not on well water, it's really what we get are symptoms that are more likely due to exposures from pollutants in the air. So we've had a couple. There's a couple things we can do when we go out to investigate at a site. We could just do, like Gabby had mentioned, doing single samples or canisters. So that's something that we can go do. Those are just samples you can collect right when somebody's maybe experiencing symptoms, or there's odors or something like that, and you can collect a single sample. It's a snapshot in time, but we can get measurements of a lot of different pollutants that could be related to oil and gas. We're also realizing that diesel fuel compounds are becoming more increasingly important as operators are beginning to use, during their drilling phase of operation, diesel-based drill muds. And so the diesel-based components are becoming something that we're looking into more on how we address that issue. And then, as Frank mentioned, we also have a dedicated mobile air monitoring lab. So we have an air quality scientist that runs that lab, and it's mobile, which means we can go out to a community and we can leave it there for a set period of time, and we can collect measurements of the VOCs, the volatile organic chemicals, over 55 of them. Volatile organic compounds, yes. And we can collect, I think, about 55 or so of those, but generally on an hourly basis. Also, we collect meteorological data with that, and I have a few more. So this is the picture of our mobile lab. We can collect ozone, meteorological data, particulate matter, the greenhouse gas emissions and different VOCs. And then we're looking to expand it to others like the diesel hydrocarbons. So what have we done so far? So far, we've gone to, I believe we've gone to at least 4 different drilling sites. All of them have been on the Front Range, and then 1 fracking and flowback site in Erie, Colorado, in Erie, Colorado. So active drilling sites near housing developments generally are the source of the major complaints, of course, right? So we generally get a variety of complaints, though: health symptoms, noise, lights, odors at the same time. While we don't address the odors and the lights and the noise, we really focus on the health symptoms. We work collaboratively with the other teams that address those other issues. Now, odors, on the other hand, sometimes really come actually quite often. When people are experiencing odors, they also have the certain health symptoms that they're experiencing. So we've responded, we've put our mobile lab out there on at least 4 active drilling sites. Like I said, we've also getting a new phase of operation during fracking and flowback to look at measurements. And generally, we're at distances at 500 feet or greater where these housing developments have been. In general, odors and health symptoms tend to be really intermittent. So they come and they go, and they're really hard to get through a grab sample or something single, right? You can go out there when a citizen complains and says, it smells really bad, I'm having a headache, and you get out there as soon as you can, and the wind direction has changed, and there's no odors anymore, and you can't, and their symptoms are gone. And that's what's been the great utility of having our mobile lab out there, is because we can collect measurements continuously for quite some long periods of time. So this is kind of an example. Crestone is an operator that's doing a lot of work up in Erie, those areas along the Front Range. They have multiple sites that are near homes. There was a neighborhood or a couple of different neighborhoods around their sites where we received over 100 odor and health complaints just from that area. We went out and we did multiple air sampling at different times, canisters, the mobile lab. We collaborated with the oil and gas operators and the Oil and Gas Commission, with Crestone also, where they allowed us to go on site and actually collect some on-site information around what chemicals might be being released, and that really allowed us to ensure that we were collecting the right thing off-site too. We looked at all of that, and I'll show you on the next slide kind of examples of what we do. So as a toxicologist, what I get are the air concentrations of all of these volatile compounds. As you can see, I think that's probably about 55 of them is what we take a look at. And then what I do is compare. So somebody asked again about benzene, so I'm just going to bring this back around to the benzene. Like Gabby stated, there's not necessarily a health regulatory standard in the same way as ozone is regulated. However, at the health department, we are taking a look at what's called benzene and others that are called air toxics. So even though there's not the same standards, we do compare those when we collect those kind of data. And so regulatory agencies like EPA, the CDC, the Centers for Disease Control, and some state governments put out different kind of standards, essentially, health limit levels that they say would be levels at which if the air concentration is below that level for a short period of time or for a long period of time, it is unlikely that there's going to be any health effects from that chemical. Does that make sense? Yeah.
I was at a tour de frac last Saturday, and the doctor...
Let me get a microphone.
Oh, yeah.
Or actually, can we hold that?
Yeah, just hold it real quick. Okay, I'll finish. So, even though I asked you a question, that's not... Okay, so what we're finding when we are looking at the mobile, taking the mobile lab, collecting the data from the mobile laboratory, and we run it against those values, EPA values. Sometimes we have to use values from California EPA, other values like that to be able to take a look. On the left-hand side here of my graph, so it's a log scale, okay? But essentially think if it's above 1, that means that the air concentration is higher than the health limit value. If it's below, it means that the air concentration is below the health limit value. We look at that for short term, exposures, and then we look at it for long-term exposures. Somebody that might be living there for 70 years and getting exposed to it continuously. So far, when we look at this individually, or even when we combine these chemicals together, you don't find that any of the pollutants are exceeding these federal or state's health limit values. Okay, unlike ozone, I suppose. Okay, so this is my last slide. Okay, so that's what we do with our investigations, and that's how we measure them. That's what we look at, are these health risks to people that are right in the community, collecting those air samples in the community, and then comparing them against health limits. All of our reports are also online. They're also mapped, so you can see where we've collected information and what type of information we've collected, and then you can go ahead and download the report if you want to take a look at those too. So, moving on.
Let's
Okay.
hold questions till
Okay, this is my last slide. No, go back. Okay. Yeah, not moving on, moving on to this. Sorry, Cassie. So one of the most exciting things that I think we're doing is you can see that our mobile lab, while it's great to get information, it's still located in one location. Remember, the air that we're collecting in a community is air not just from oil and gas, it's from everywhere, right? We have the meteorological data that we can look at, and just like the wind plumes that Gabby had shown, we can develop wind plumes so that we can also look at that and compare it to, oh, this is kind of coming from the oil and gas site. We think that these contaminants are coming from the oil and gas site. But again, it's total, it's total amount of compounds in the air, not just oil and gas. So we were recently funded by legislature to oversee a risk assessment to evaluate the health risks directly attributable to oil and gas emissions. And the fantastic work that was done, fortunately, you've got to raise your hand. Thank you. By Arsene and Jeff Collett at Colorado State University here, and also in collaboration with our environmental team at the Department of, so essentially they collected, what did it go for 3 years? For 3 years, they went around and collected data that got rates of emissions of individual volatile compounds coming off of the different phases of operation. So drilling, fracking, flowback, production. And we have information now on those rates of emissions directly coming off of oil and gas emissions. The great thing about that is now you can take that information, you can put it into models that will use those concentrations, and then based on meteorological data, you can look at dispersion of what those pollutants will be at 500 feet, which is the current setback, or 1,000 or others, right? So you can take a look at what are your air concentrations going to be of these different pollutants at different distances. And then you can take those air concentrations, and now we can do something just like I showed you with those investigations and look at what could the health risks be to people at those different distances. Again, what's great about this is it's for the first time understanding what's directly attributable to oil and gas activities. Right now we have, general ambient air data. So the data, it will be completed. We have the data. It's about halfway done. The study is about halfway done through the consultant that we've hired, and we're looking to have a completion of it sometime in late summer of next year, 2018. Okay, so bottom line, if you're interested, if oil and gas ends up coming into your area, right now, the current issues that we really get are mainly around during the drilling phase. Like I said, a lot of people report odors and health symptoms when those odors are occurring, and their health symptoms leave when the odors are gone. Again, mainly during drilling phase, we don't know if that's primarily because now they're using more diesel-based muds, which are pretty odorous, and that can cause, so the odors in and of themselves, even though it might not be from a toxic health limit value, the odors that in and of themselves can cause symptoms to people. Just like you can get a headache from your coworker that's wearing a pretty nauseous perfume. So it's real symptoms I think people are experiencing. It's just not the way you measure them sometimes through a risk assessment in that area. So they're still really important for us to be getting these kind of complaints so that we can understand this information. We also ask, sometimes we partner with the citizens to get logs so they can log when they're getting these symptoms, what time of day, or do odors occur with it, describing them, because we can start to get patterns to take a look at when we're getting early or late night types of symptoms. So there's patterns to it too. All right, so where are we going now? Well, from my perspective as a toxicologist, we need better exposure data. We really need better exposure data. That's what we're getting from the CSU study and doing more community air sampling. We can put our mobile lab out there, we can collect an air sample, but it's a snapshot in time. We don't get all the phases, and we're not getting in every direction of a community. So continuing to do and collect better exposure data so we can understand what people might be getting exposed to is really, really important for us to understand the health risks. And again, the systematic collection. So that's why I've been going around to the local counties over the last couple of years since we started the program. So people are aware that we exist, so we're actually collecting data if people are experiencing symptoms. So we're getting it all consolidated in one place. And like I said, the biggest thing we're excited about is having this risk assessment that has never really been done before across the nation to look at the risks related to emissions directly from oil and gas. Thank you.
Thank you. Okay. So I know some people, let me see a show of hands. Let's do this so we can help gauge how many people might have questions. And I would also ask, let's at least start with questions more than comments. So if you could definitely have a question, that would help. And I started in the front last time, so I'll start in the back and work my way forward. And then maybe if you could use that mic there. Thanks.
Hi, I'm actually with Larimer County Board of Health.
Great.
And so we talk about CDPHE all the time. And
Hopefully in a good way.
Of course, of course. And I've also, well, anyway, get to the question. The health risk assessment sounds great. What I would like to see, though, is the health risks of the oil and gas workers who actually work at the sites, not just citizens who are 500, because the other presentation we had about a year ago, the dispersion showed 500 feet and stuff was ambient by 500 feet. So, but it's the workers who are within the 500 feet all the time. I would really like to see you guys get a database of the workers. But so the question there, is there any yet?
Good. Yeah, no, that's a really good question. We've been talking about that because the people within my own branch, we've just, well, I guess within the last year, we've brought on board an occupational health specialist. And so she is actually starting to work with NIOSH to start to see kind of what data they have and could they develop some collaborations with oil and gas and maybe get some data where they could, just put it into a repository, the data that they already have and track on workers. That's probably about as much as I know right now with that. I mean, we've talked about it several times, and I don't know how far she's gotten in that in the last couple of months. But yeah, absolutely. I mean, because one of the things we've also said is, we'd like to know what are the exposures, on site, because then it helps us to extrapolate to understand what people might be getting, the concentrations people are getting exposed to off-site too, right? So I can tell you for every assessment we have done so far, benzene is always, I would say, our indicator compound, that if we can track benzene and assess that, I think we're starting to feel pretty comfortable that the rest of the chemicals are going to be lower from a health risk perspective. But benzene inches its way up to getting pretty close sometimes. Yeah, that's a good question.
Yeah, mine's yes, I went to the Tour de Frac last Saturday on the 11th. And a doctor that spoke talked about there was absolutely no safe level of benzene. Is that not accurate? I mean, if there's any benzene, it's toxic. And he also talked about living within 10 miles of fracking was the danger area. And it was pretty much, I mean, yeah, it'll probably be more concentrated in the center, but that nothing less than 10 miles was actually safe within fracking. Oh, no.
No, I can. No, yeah, that's a really, really good question. Absolutely, which is why caution about using the word safe. And with benzene, you're right. Benzene can cause cancer. And when we talk about cancer, they talk about it from the sense of that, any additional concentration of benzene could increase your risk of getting cancer potentially. So what we look at, so benzene can cause cancer, that's well known. Benzene also has non-cancer type health effects that we get concerned about too. When we look at the risks, EPA kind of has this established range of what the risk level would be for cancer, not just for benzene, but what would be 1 in a million to 1 in 10,000 people above background, okay? Above what people would already get background from natural, getting cancer anyway. And we look at what would be the level above background that additional exposure could be causing. And that's what what I need to clarify is that what we're not seeing is a significant increase from what would be a background exposure to where generally EPA would say this is a clear cut increase in cancer rates potentially from benzene. And then your last, you made another good comment real quickly that I wanted to.
He was saying the doctor.
Oh, yes. Yes, okay, so.
10 miles.
So there's been several different studies that have been done. Up until the work that we recently did, there hadn't been any comprehensive evaluation of all those types of studies. So that is one epidemiological study that looked at different health effects. The report that I said you can get online that we looked at a variety of different studies, and what we did is we looked at the evidence for and we looked at the evidence against certain health effects. And I don't know what health effect he was looking at from that study, but I wouldn't say that there's real clear-cut evidence that 10 miles out is still a health concern. So does that answer it?
I was just wondering if he was correct.
Well,
he's a
I would
doctor
say
and he
that-
studied it, so I thought maybe it was.
Did he
Yeah.
do it?
I believe he
was-
did.
Oh, he's the author of the study?
I could get you his name. I have it in the
Yeah,
info, but
sure.
I didn't bring it with me.
Sure.
Yeah.
Okay,
So, yeah, if you want me to, I can get you his
Sure.
name. Okay.
thank you.
I was just wondering, how many studies or air samplings have you taken during the flow back and for up to 2 weeks after flow back? How many of your studies have been inclusive with those, that phenomenon?
Okay, that's a good question.
It's usually the highest.
That's correct. We just did that work. We had our mobile lab out during a flowback event. Let's see, we had it out there for about 2 weeks. I'd have to do the math. So you're getting 2 weeks, taking hourly samples, 24 hours a day, 7 days a week. So we haven't taken a look at that data from flowback yet. I mean, we have seen that the concentrations are higher than what we see for some chemicals during drilling. But we didn't see anything, at least I haven't taken a look at all the data yet, but what we were getting alerted by our air quality scientist when he saw spikes. And from what he was seeing, they still weren't hitting something like that was from an acute perspective we were concerned too much about. But there's definitely differences, and Arsenic can speak to that too. There was differences based on their study too with flowback and the emission rates. Arsenic, can you define flowback a little better than I could? I don't mean to put you on the spot. But I mean, I could in a very elementary way.
So when they start to do the fracking, they drill down and then. So when they start the fracking after drilling, they put some charges inside of the wellbore that they've drilled, and then those charges cause fissures, and then they put in sand and water and chemicals in high pressure into the wellbore, and then they do this in sections, and then after each section is done, they put a plug on it. So now you have sand, water, chemical inside of that section of the wellbore. When all of that is done, the entire well, which can be a few thousand feet, then they have the last plug, so then they drill it out. When they drill out, Then this water and some of the chemicals and the oil and gas or gas that's in there comes back up with high pressure. After the drill out, the process is called flowback because things are flowing back.
So what you're getting are the natural hydrocarbons, the oil and gas coming up, along with the other chemicals that they injected down there, and sand and all of those types of things. And then they move it straight into production, and that's what you see as the individual wells that are out there. Yes.
Hi, I had a question regarding T-norm, the naturally occurring radioactive material. There have been recently questions regarding that in the state of Colorado. First of all, do you guys ever go out and evaluate any tailings or cuttings on site, or
That's a good question that I don't have
or
a
where they're
lot.
disposing of them?
So we haven't had anybody call with regard to, issues around that or questions
I'll
around
call
that.
ya.
No, please do. No, I'm just saying. So my knowledge around that is just a little bit limited right now. But I do know that there's some people in our environmental group that are working on that, and I'd be
Yes,
happy
yes.
to get you in touch with them if you
Please.
or answer some specific questions that you have.
Yes.
So
I'll
that's
take their names. for
yeah,
sure.
absolutely. Because
'Cause do you know where they're putting them?
I don't.
Yeah.
I don't know.
I
I don't have that. I'm not sure.
Okay, so
You do?
we'll take some notes on, oh, there we go. We got a card right there. So thank you. Here we go.
Hi. So you showed a graph with the information with 50-ish compounds that you measure, but not all of them are regulated. So the concentrations, is the Department of Public Health thinking about expanding their regulations for a bigger amount of compounds?
So, regulated from the standpoint of like what we were talking about
Exposure.
with ozone or NOx or SOx. So those are criteria air pollutants. Gabby, correct me if I'm wrong about but those are regulated at a federal level too, right? And we've adopted those at the state level. So we do measure these air toxics, which is more of what I'm talking about, which are kind of under this category by EPA called air toxics. Some of them are, some of them aren't on there. But air toxics are hazardous chemicals that we're concerned about at some level that would be in your air. And we still have levels that we can compare them to. But you're right, they're not under the same regulatory type standards where you'd be in attainment or non-attainment. There's definitely different approaches to the way they're dealt with. And you mentioned it very well, that state by state deal with them quite differently. So what our Air Pollution Control Division does is they have air toxics monitors along the Front Range and other areas across the state where they're annually measuring those from a regional air quality perspective too. And we take a look at those data to
Yeah, but
ensure that they're not.
There is no limit that you consider, oh, this is high, oh, this is low, or that us can just put a bar and say, we're here, this is higher or lower than it should be.
They're just not regulated. So what I mean by regulated is that there's not the same kind of violations or implications from the perspective of.
So how can we find those?
Oh, the limits, the
Yeah.
health limit levels? Yeah, so absolutely. So if you go, let me go back and explain that I might have not explained as well as I could. Okay, so I don't show the levels on here. All I show is what you would call a ratio. So we compare the air concentration in the measurement we took to some standard, right? So some level of, where they say maybe below, this is for non-cancer health effects. So below that level, it's unlikely that there's going to be health effects. Above it, so that's what we do. We kind of go above and below one. It's kind of that simple. If you want the actual values we compare against, we put those in all of our reports. So you could get online and take a look at our report, and you can see this is the value we used. It came from US EPA or it came from California EPA. and these were the air concentrations of the measurements we collected there. Does that help answer? Okay.
Is there any reason why funding was not provided in the health risk assessment for mining, just for gas and oil? Because there is the issue of particulates as well.
I don't know that answer. I know that specifically based on the task force recommendations that I mentioned earlier, one of the recommendations was to have that risk assessment conducted. And then also there was just funding available. There was funding available through multiple sources that CSU were provided to do that type of research specific around oil and gas. The other component of that was understanding probably, I suspect, Arsene, around this contribution of oil and gas to total emissions. So it kind of circles back to what Gabby and Frank were talking about too in a lot of ways. So from a mining perspective, I don't know. I'm not sure. But if there's a mining operation, our environmental group, not just, we don't just evaluate and model emissions from oil and gas. We model emissions from multiple types of sources. So there might be activities going on. I mean, I could find out more for you about this specific mine you might be interested in.
Please, because
Sure.
Marietta and then another 123-acre purchase is enveloping or
Wow.
enveloping the town. There is a subdivision literally.
Oh, I think I might have heard about this.
It's
Okay.
thank you for the opportunity to be heard.
Absolutely. No, I'd be happy to hear. We can talk more afterward. Okay.
Going back to the talk about the individual chemicals. So you started your talk saying that there was very little epidemiological data on exposures from oil and gas operations, and also that the standards are not necessarily as robust as for some other, like ozone and some of the other highly regulated. So it's hard to make a risk assessment without good data. There aren't a lot of epidemiological studies for these air toxics that you're talking about. And I know it's expensive to do these studies. A lot of them are done in animals, but it's really expensive to do the studies on chemical mixtures. And part of what is the problem with these oil and gas emissions is that they're chemical mixtures.
Mm-hmm.
So some of these chemicals are antagonistic or synergistic, and so you're going to have different health effects from exposures to chemical mixtures.
So those are a few good points. I'll see if I can remember all of them.
Okay.
Do you want me to address a little bit, or was it more just a comment?
I'd like to get to actual questions
Okay.
and make sure that we work our way through, because I want
Sure.
everyone to have an opportunity,
Okay.
but we can certainly
We can talk
come
about
back.
that more too.
Yeah. All right, question.
Good points.
While we're on this slide, my question was, you said that these air toxics aren't regulated, so there's no, and you've also determined that they're not exceeding any federal or state health limits, but then where does that leave residents who experience these symptoms, and what closure do they get from you doing these studies?
So that's a fantastic question. I think it's a real challenge that we're facing as we're starting to collect these type of data. We assess things based on, like I said, these standard federal state agency limits that are for long-term irreversible type health effects. Okay, so an exposure to a chemical that will cause an irreversible effect, in the long term, not necessarily something that those standards don't apply to something that would be a temporary type effect that are established by EPA or other agencies. So especially due to odors. So oil and gas is not the only type of source sometimes that causes odors. We can talk about pig farms and all of those kinds of things, that the same issue happens in a lot of different types of industries when there's odors present people can experience certain types of health symptoms. And it's still really real. And it's a real challenge. How do we address this issue? And that's something that we're really talking about seriously, the Health Department, and working with the Oil and Gas Commission too. One of the things that we've done, for example, at that site that I was showing you, is the Oil and Gas Commission put a lot of pressure on those operators too to mitigate those odors. Because so there's also odor standards in place, or odor regulations that are in place, both through the Oil and Gas Commission and through our team, well, the Air Pollution Control Division oil and gas inspectors. It's just, again, it's challenging to get out there, an inspector, to smell those specific odors and regulate by the time they get out there. It's a really, really tough issue. So one of the things is always, okay, we're not finding that these levels are anticipating that would be causing any long-term type health effects. However, we still are concerned about these types of short-term symptoms people are experiencing. And so really a lot of it has to become with relationship building with these operators. Do you want to be a good neighbor and do something to mitigate these exposures above and beyond what regulations state? So that's been the way we've been trying to deal with this right now as we begin to see more and more of these issues happening. But I have to be honest, people are frustrated by some of that. They really are, because it's a real challenge. So,
Thank you. I want to lay something out, and I can end up as a request or a question, however we want to phrase that. So I'm interested in, I know that the CSU studies are very high quality and give us information we haven't had before, and we could certainly put those in models, and that's fine. You're responding to health complaints, which it sounds like you think people are really experiencing. And so in some cases, then you're deploying a mobile sampling station that can measure a lot of compounds. The part that I'm not seeing that confuses me is if there's an active oil and gas operation, why you're not making measurements right at the boundary of that operation to characterize that source. Because if you did that, you would be getting data that helps understand how representative the CSU studies were. It also could then be applied in models.
yes.
And it's an estimate of the emissions as they're leaving the site. The ambient air starts at the edge of the drill site, right? It's not 500 feet or 1,000 feet downwind. So would you be willing to consider adding that to your protocol?
Oh, I think it's a fantastic idea, and we were talking about this all the time. If we ever have some downtime with our mobile lab and not responding to, so the primary intent of the mobile lab was to get out into the communities where there are health symptoms being reported and understand the air concentrations there, so the true exposures to people. So, but what you're saying is we absolutely have been talking about this with Arsene and Jeff too, about really validating these models, right? So this is going to be some of the data we're collecting might, and to some extent, but we really haven't put a really good kind of thoughtful study together to think about how we could start to validate those models. And as you can see from Gabby and, from their work, it's important to try to validate some of the models and the assumptions that you have. So based on that, yes, what you're talking about is something we've been thinking about a lot. And how could we deploy the lab in different ways in order to collect some data to start to validate maybe, results that we get next year. No, it's a really good point.
Hi, Tammy. Two questions. So what you're doing with the health division is kind of collaborative with not only constituents but also with the operators too. But your environmental section out of your group over there has got compliance and enforcement responsibilities too. So how does that work for you? Going on and trying to establish that relationship, that working relationship with the operators when they know that there's CDs that come out of that process. There's compliance and other punishments that come out of that process too. Are you viewed as a cop, or do you have a way that you can work with these guys to give them immunity in the process when you're working with them?
No, I think that's a really, really good point. And it's, so we tread lightly. I also make it very clear that I am not the regulatory side. So my program does not have regulatory authority. We're really just evaluating the health effects. And so It depends on the operator, I'll be honest. I mean, some operators have been fantastic to work with. I started early on with the intent that I thought it was important to establish some relationships with these operators because that's the way that we can get some data and also understand their processes and those types of things too. But also, I think it's important that when we get calls from citizens, like symptoms and others, we are expected actually by our legislator as part of what they put together for our program is that we are also letting the operators know about these things. Because if people are being exposed, we need to let the operators know so they get out there and they check to make sure there's not something going wrong on their site. At the same time, our oil and gas inspectors in our environmental group will be deployed, usually, especially if there's, several complaints coming. The Oil and Gas Commission usually goes out, so it's this giant kind of communication network we've got to deal with. Usually it'll be our agencies that talk, amongst ourselves to understand what each part of us, what we've done, what information we have, before, we approach kind of the operator with some of that, like, mitigation or those kinds of things. So we can make some recommendations, but usually it will come around with mitigation. It'll be the Oil and Gas Commission or our inspectors that will talk to them kind of directly to deal with, like, this needs to be mitigated. Even though there's not a violation, do the right thing and try to mitigate these odors. That's like a good example. I don't have a clear answer. It's tough sometimes.
I'm
some
just
might
curious.
view me
It's
as a
kind of
friend, and some might view us as a foe too.
It's kind of
But-
double duty, They might be perceiving you as being a threat for them.
Yeah, they did it first. Oh, yeah.
Depending on the way that you kind of
Mhm.
constructed the position for the data for them.
They did.
So,
I think they absolutely did, and they were very concerned about us going out there. I think the biggest concern they had was that we would collect good, high-quality data and what we would actually do with it. So,
the second-
so we have to be very cautious about making sure that we're as objective as we can as scientists to stay out of the realm of all the other stuff.
Second question is on the ozone.
Yeah.
And I know you didn't cover that much in your presentation, but your toxicology side of things. What is the physiology of the threat for ozone for constituents? Are we talking pneumonitis in terms of the way it presents itself, or what are the primary threats that we see from that?
Well, you get a lot of symptoms that people are reporting. Gabby, and you guys could share too if you know a little bit more about that. But in general, with ozone too, that a lot of the same kind of symptoms. You also get increased asthma rates or other things like that. So, but a lot of the respiratory type symptoms or eye, nose, throat irritation, that kind of stuff. So the symptoms are pretty consistent with what you would think with ozone too. We have taken a look at what our mobile lab has gotten out from ozone levels, and they haven't hit anywhere locally around that with any of the 8-hour or California EPA has a 1-hour ozone standard, so we've compared it to that too. They haven't. So,
Hold on, if you would.
I have to say that now also, that earlier the comment was made that the health limits for the criteria pollutants such as ozone are robust, and I think you made that comment or somebody, and I wouldn't say that they are robust. There is more health studies out there, but the 70 ppb, the way it's regulated, doesn't mean that it's totally robust. Plus, it's not that at 70.1 ppb, you breathe unhealthy air, and at 69.9, you are just fine. So there is still a lot of wiggle room in that also.
Yeah.
It's a guidance, but no more.
And Gabby, that's a great way to put it. These are all guidance levels, okay? So as a toxicologist or risk assessor, we're not going to go, oh, you know what, it's not below, it's not hitting the one, no problem. It's not black and white like that. We do think about things like mixtures, to the best of what science has around what mixtures are and additive assumptions and some of those things, because you have to think about that. So when we do these types of studies, we're always looking at, okay, we've got a whole bunch of compounds. Are there ones that we're identifying that are really high priority here that we need to go out and do more testing on, really, right? Like, you're not just going to collect one air canister sample and you get levels that might be close to the 1 limit and your exposure levels and then say, well, that's it. You know, you're going to go out and do more thorough testing. So sometimes it's around how do you take that information, because it's a guidance level, they're not a regulatory standard, you have to really, you know, get really good quality air, you know, data. So, good point.
I was going to say one more thing, that one of the reasons we have, you know, relatively established values for ozone is that there's hundreds of ozone sensors around the country. If you try and get benzene data from around the country, good luck with that. It's essentially going to be limited to scientific studies. Another thing to what you mentioned is one of the problems with epidemiological studies is that you have to usually wait a very long time before you see the effects of something like that, especially compound type of things. You know, there are, you know, this has probably 20 aromatics in it. You know, you add them all up and you get way over 1. You know, I might also mention that during our study we measured.
We've done that. You don't.
Yeah, we measured some. Well, you know.
Yeah, it depends.
I mean, I can give you a place
Yeah.
where you can get that benzene bar go to 120.
Yes, I know that data.
Okay, so you know, so like, it's not like, you know, this is from Erie, and it's
Yeah.
good that it isn't higher, like, because there are literally
Yes.
thousands of people living close to that place.
Yep.
Downwind of it, downhill from it. I actually happened to visit that.
You know what I'm
Dan while
talking
he was
about.
measuring
Yeah,
there.
yeah.
And what's funny, that's something that you mentioned, there were actually 2 passers-by from the neighborhood that were very unhappy with the fact that the state was spending taxpayers' money to make measurements.
Oh, yeah.
So there's also the other side of the
Good point.
population.
Any questions on these front 2 rows? I'm working my way this way.
Just a quick one. You were saying there were 400 cases that were reported that
So far.
called you since
Yeah.
you guys have opened.
Mhm.
So once they call, how soon do you get there?
Well, we don't go out on a site investigation for every call. It usually will be if we're getting multiple calls, and it's pretty obvious. If there's a site that's having a problem, because you get lots of calls at the same time. But we will, it just depends on what the question is, or if they're having health symptoms. We'll either work with the local county where they are close by and see what might be happening. Sometimes we'll go out, but that depends on how quick. If it's an odor related, if it's issue with odor or noise or any of those types of things, the Oil and Gas Commission or air pollution inspectors get out, and they're out there within hours usually. So they have to respond like that to
Can you
every
give me
complaint.
an average of when you go out, once you've gotten someone call, say 6 people call you?
Yeah, we might sometimes go out that afternoon.
How often do you think
So-
you've been able to get out that fast? In those 400 and the ones that you actually went out on?
Yeah, I would say probably all of them we get out within the next day, the ones we've had, because what we see is, like I said, we get like 100 complaints in a matter of a couple of days from the same site. So we're not, you know, these aren't sporadic. These are clearly clusters of communities that are experiencing something, and we try to get out there, you know, either that afternoon if somebody's called, or the next day if our staff can get out there to figure out what's going on. Yeah, that's a really good question. How long we get to leave the mobile lab out there? So the mobile lab, I will clarify that we do not get the mobile lab out there that same afternoon. Okay, we might have like our investigator or staff get out there to understand the situation and talk with the citizens. The mobile lab, it takes time to get that up and going and deployed. But when we get it out there as soon as we can, it can either be out there, it depends. If it's running on a generator, it can be out there for maybe up to a week because it's running on a generator, so that's the limit we can do. But like in Erie, we worked with the city, and they actually put in permanent electricity. So we were able to put our mobile lab out there and keep it out there during fracking for, I want to say almost 3 weeks. 2 times we went out, 2 events, over a total of a 3-week period, and now we're back there for flowback during that second phase, and we kept it out there for 2 weeks. This, I believe, is one of them from one of the Erie sites. Yeah. Sure, go ahead.
In looking at risk, sometimes you can look at voluntary risk versus involuntary risk. Many of us probably wouldn't voluntarily live next to an oil and gas site, which kind of makes oil and gas emissions an involuntary risk. However, on the other side, you know, many of us in this room drive gasoline-powered vehicles, which gasoline contains the majority of those compounds up there. And, you know, many of us don't worry on a daily basis about the gas emission or the emissions that are coming from the gas tank in our car, the tailpipe in our car. When you fuel up your tank at a gas station, I mean, you're getting, for short periods of time, you can be getting very high levels of many of these compounds.
That's correct.
So do you talk with folks and kind of, how do you talk with folks, I guess, to kind of deal with the involuntary risk of, yeah, something is coming over my back fence and is coming into my yard that's not of my choosing, namely an involuntary risk, versus every single day, you know, many of us come in contact with gasoline or gasoline-powered vehicles, or even just sitting here in this building as cars are driving by on the street out here. I mean, we're all being exposed to benzene in many of these compounds. So how do you talk to people about those two kind of risks, or do you talk to people about those kind of risks?
That's such a good question. So you're absolutely right. When you from a science, from an exposure standpoint, you're right. So objectively, those two make sense, right? That you are being exposed. There is no way. Yes, there's no safe level of benzene. And if you would like to not have any cars or anything in the state, so we never have any benzene, that would be ideal. However, we never talk to people about comparing voluntary and involuntary. I will tell you, it never works. You don't go there, because when people feel threatened by something that they don't have control over, it is a very different type of risk to them, even though objectively it might be the same type of risk as something else they're getting exposed to. It's very hard for people to deal with. I mean, and so it doesn't help the conversation if I try to bring in something about like voluntary type risks as comparison. I've learned that. And then I hire expert world-renowned risk communicators to learn how to, because it is a really tough situation. This oil and gas thing, I mean, it's just tough. It's involuntary. It's high concern. People are concerned about their children. They're concerned about, you know, right, like you said, right next to it in their backyard. Often they don't know that it's coming in until it's right there. So it's a really tough thing to talk with people. Most of the time, I would tell you that citizens, when we do our reports and studies and we have our findings, fortunately, we haven't seen anything in the communities so far. I will tell you that people generally, some people say, well, it's not very helpful to us because we're still frustrated. We won't be happy until it's gone. Other people are glad that at least they know now what their concentrations are, what the health risks are from a long-term standpoint, but they're still not completely satisfied because it's there. And at least, I mean, I get it. It's just a really tough thing.
So assuming benzene is a carcinogen, and I think you're right, I remember there was this federal law called the Toxic Substances Control Act, and it established a toxic release inventory or toxic registry inventory. Right. And so if carcinogens are included on the toxic release inventory, would there not be some national data about benzene from the TRI, or would there not be some standards under the Toxic Substances Control Act that pertain to benzene, apart from all these federal health limits?
So I'm slightly familiar with the registry, but I don't know it completely accurately. Frank, I don't think that there's not emission databases of benzene, are there? Yeah. Okay. Yeah, go ahead. So he'll answer that better. Huh?
But there are benzene emissions. You know, the benzene is well, so if you look at the inventory on the web, you get a VOC number. And then you run a program that will look at where you are, and it will split that up into the different compounds, and that's what your emissions are for a certain area. And that depends on what, all these relative factors. And there's a whole bunch of magic going on.
Interesting, okay.
But you can get a total benzene emission for a 4 kilometer square in the middle of Denver versus, somewhere, wherever you want, okay? Now, when we evaluated those emissions here, we found that the traffic emissions, benzene is emitted from traffic, relatively small amounts. Benzene in fuel has been reduced dramatically since, 15 years ago or 20 years ago. There's not all that much benzene in fuel anymore. So when we evaluated the benzene for the Denver urban area, the emissions were fairly good. When we evaluated the benzene for the oil and gas area, benzene was somewhere between a factor of 2 to 4 higher than what we would have expected had we used the emission inventory. That was in line with all the other VOCs from oil and gas. So that means that at least for the relative mix of oil and gas emissions, the emission inventory isn't so bad. It's just the total numbers that can be off. Okay. Now, since we did the study, there have been some improvements. For the oil and gas industry is doing more pipelining. They're trucking less. A lot of those emissions come from the condensates, the tanks that are sitting there.
The unloading, all of that.
And those are being reduced. There's more and more pipelining going on, which is going to be helping that a lot. So we would love to do this again to see what it is now. What I can tell you is that the benzene levels in Platteville, for one place, are about somewhere between 5 and 10 times higher than the benzene levels in downtown Denver.
Yes.
Okay, so it's not quite accurate when you say you stand by the side of a road and you're breathing this benzene. You do breathe a little bit of benzene, but if you stand in Platteville, you're breathing a lot more benzene.
Yeah.
Okay, so it all depends on where you are, and it all depends on what time of the day it is. The other thing is the nighttime pooling of emissions is really important. That is another thing. If I was at this Erie site, and these houses they are in this depression. The highway is, I believe it is Highway 52 that goes to the south, and then there's this depression, and the neighborhood is in there, and the oil and gas is on the hill, and then there's the landfill on top of that. So it's just a lovely place, right? I mean, just where you want to live.
2 landfills.
Those places could potentially, at 4 in the morning, experience some pretty high emissions. And Dan being there 24/7 was probably a good idea. To kind of get an idea.
It is, because that's when people complain of
we
the
had
odors.
We had a continuous measurement in Platteville day and night during frappe, and the nighttime benzene values there were pretty scary.
Yeah. Scary.
I know. All right, can we give Tammy a hand for coming down and doing this?
Thank you.
Yes. Thank you. I want to be respectful of time. I know I saw some late hands. I think you can probably catch folks here in the last couple minutes if you still have questions. Richard, do you want to say anything wrapping up? Are there next steps? Are these studies available elsewhere? Anything? Okay. Richard has no additional details. We will thank you all for coming and appreciate it.
And also, copies of the NCAR reports are available online, Fort Collins Air Quality site.